All right, guys, this is Unit 7, Topic 7.6, which is on the reduction of air pollution. So, we're going to talk today a little bit about how we can kind of decrease some of these air pollutants that we've talked about. We've briefly talked about a couple of different things, but really the best way to, I guess, decrease air pollution is to just kind of avoid using certain things in the first place, and which really isn't so easy. I mean, it's. I'll go back to photochemical smog that we talked about yesterday. Photochemical smog. One of the biggest things that causes it is the production of NO2, right? Producing those NOx compounds, which are mainly produced from automobile emissions. So what, you're just going to tell people to not like use cars? I mean, it's not really that easy of a solution. But I want to discuss today a few of the major air pollutants that we really need to sort of focus on, and we have been focusing on for quite a while now. But ways that we can possibly reduce these particular compounds from getting into the air. So we're going to talk about NOx today a little bit more. What are some things we can do with that? SO2, sulfur dioxide, particulate matter. Again, there's some things that we can do to manage how much of that gets into the air. Vox, we did discuss this one yesterday. For example, I talked about covering your paint cans, when you're done using paint. I talked about not spilling gasoline in your garage or when you're filling up your lawnmower. Those are some things that we can kind of control. But as far as these other things, NOx, for example, and SO2, both of these things, besides, like NOx being something that's kind of a precursor to photochemical smog. Both of these compounds are contributors of acid rain. Now, we will talk about acid rain more in tomorrow's lecture, but acid rain is pretty bad for the environment. It creates an acidic an acidic pH. With precipitation, it can contribute to altering the biodiversity of lakes and rivers and things like that. But again, NOx can also be a part of photochemical smog. So these are some things that we really have to look at and sort of control them. So we're going to look at three different methods that we kind of use to help limit either NOx or SO2. One of them is called using low sulfur coal. We'll talk about that one first. Sulfur dioxide scrubbers. These are mainly devices used in coal power plants to help reduce sulfur emissions. And then catalytic converters. We talked about this yesterday. I'm not going to go back into it, but catalytic converters are engine components that are used to control the exhaust gases that come out of our automobiles, which will really limit the amount of NOx that can be put into the atmosphere. So that's kind of a good thing. Problem is, we still, there's millions and millions of cars every single year that are producing minimal amounts of NOx, but because there's so many of them, it ends up being quite a bit. All right, so let's talk about low sulfur coal. Let's revisit this diagram. We've talked about it before. There's some different types of coal, that form. Remember, coal all comes from plants that were alive, like when the dinosaurs walked the earth. But the first thing that those plants turn into is peat, which is not coal, but it's kind of the precursor to other forms of coal. Then we have lignite, we have bituminous coal, which is mainly what we burn for electricity. We also have anthracite. Now, one of the big differences between these last three is the amount of sulfur that is in the coal. Anthracite, also known as hard coal, has a very low sulfur content. So when we burn it, it actually doesn't produce a lot of sulfur dioxide. The problem with anthracite is there's not a lot of it left on this planet. We've actually mined for so much of it that we're running out of it. And whatever there is left is usually really expensive to get a hold of. So if let's say you own a coal power plant and you're going to be burning coal to produce electricity, Do you want to spend a lot of money on anthracite, or do you want to spend a little bit less money on bituminous coal, where it burns just as easily and produces just as much heat, but it also does have a higher sulfur content? Well, in this country and a lot of places around the world, bituminous is the winner because it's less expensive. Now, to combat this problem with sulfur and sulfur dioxide, which is one of our 6 criteria air pollutants, a lot of power plants, especially in the developed world, use something called sulfur dioxide scrubbers. The nice thing about sulfur dioxide scrubbers is that they completely limit how much sulfur dioxide can be released into the environment. It really minimizes that. Now, how they work, it's actually really, really easy. Um, let's say you're going to burn coal in your power plant, and normally all those waste gases would just go out through the smokestack, throughout the exhaust pipes of the factory. But instead, these waste gases enter the scrubber. Now, inside of the scrubber is something called limestone. It's also known as calcium carbonate. Now, when calcium carbonate reacts with sulfur dioxide, it produces something called gypsum. It's otherwise known as calcium sulfate. Now, gypsum is actually a recyclable material. It's actually used to make like drywall, wallboard. It's even used to make dental impressions. Cement is used to make some cement from it. So this is a product that, instead of releasing all those gases into the environment that has all that sulfur dioxide in it, we can react it with limestone to create a compound that we can use, for our own benefit. These are all things that are made from gypsum. Even things like casts for your arm, and again, dental impressions, drywall. All of these things are made from that particular product. So it actually is a lot better for the environment to produce these products than to release all that sulfur dioxide into the air. It's actually a lot better. I'm going to go back to this real quick. The one, I guess, negative with this is they are expensive. So if you're going to install one of these in your power plant, it might cost millions of dollars to install it. In some countries around the world, that's a huge issue. In the United States, maybe not as much, because maybe you'll get some kind of government incentive, or rebates or something if you do install those things. But other countries, they may not get those. Um, Particulate matter. Now, particulates are another major form of air pollution that, again, is typically produced in coal power plants. It's a component of a lot of industrial pollution. And there's 4 different methods that we use to kind of help control those particulates. Now, you got to remember, we talked about a couple days ago, um, whenever it comes to particulates, size matters, right? There's those PM10s and those PM 2.5s, and they even have like particles that are as big as 50s. So these particles have to be removed. They can't be allowed to linger in the atmosphere, because, again, they can cause a lot of air pollution problems. Now, there's 4 different ways that we can kind of resolve this problem. And I'm going to tell you ahead, but before I get into this, um, I'm going to suggest to you that of these 4 that I'm going to explain, um, maybe learn like 2 of them, like focus on 2 of them that you can explain. Because on the AP exam, if they, let's say, perchance they ask you to describe a method of controlling particulate matter in the air, well, any one of these things would work. Again, I would say get familiar with maybe 2 of them. Um, but you have to be able to describe it, like, in detail. So let's start with this one. This is called a gravitational settling chamber. And again, this would be, again, probably something you would see in a factory, maybe in a coal power plant, anywhere where they're producing emissions that have particulates in them. This would be used for removing particles that are much larger, maybe 50 micrometers or bigger. These would be things that are probably visible in the air that you want to get rid of. So what happens in these, basically, as the gases pass through, and we have a special name for those gases. They're called flue gases. They're basically just exhaust gases from the factory. But those things would pass through it. But because of gravity pulling down on the heavier particles, those heavier particulates would just fall into these, they call them dust hoppers, and they just collect all those bigger particulates. Now, the smaller ones would probably pass through. So this would not be a device that would be used to remove the really small particles, but it would probably be very effective at removing the larger ones. This is called a baghouse filter. Basically, what they use here are filter bags. Almost kind of like your furnace filters in your house a little bit. If you don't know what those are, I'm sure you can probably ask your dad what one looks like. You kind of take a look at it. But again, here we have an inlet. This is where the dirty air goes in, and out the other side of it will come the cleaner air. So the dirty air will come in filled with particulate matter, and those filter bags will filter out the larger particles, and then the air will escape through the top. It'll be much cleaner. So kind of like the gravitational settling chamber, the air that comes in is dirty, it's filled with particulates. The air coming out the other side will have less particulates in it. And that's what all these things are really designed to do. This is called an electrostatic precipitator. This one's a little bit fancier, it's probably a little bit more expensive. But again, take a look here. We have our dirty air, filled with particulates coming through. Now, in this case, what happens is that dirty air that flows through comes in contact with a negatively charged electrode. So what this electrode does is it gives these air particles, it gives these particulates a negative charge to them. So when they pass through, there's these collecting, I don't know what you call them, but I guess they're collecting devices, but these are positively charged. So any of those negative particulates that pass through are going to stick to these collections or to these collective devices. And you'll notice as it passes through how this first one is really dirty, then the next one's a little bit cleaner, the third one's a little bit cleaner. And that's telling us that as that air is moving through, the air is getting cleaner as it passes through. Then all of those particles will be collected in a hopper and then they can be removed. So again, we're taking dirty air, passing it through, and there's cleaner air coming out the other side. Another one, this is one of my favorites. This one is called a particle scrubber. Again, the same thing. Dirty air comes in that's filled with particulates. And inside of this scrubber is basically a bunch of little sprinklers that give out like a little mist of water. And all of that water will actually adhere, it'll stick to the particulates and it'll make them heavier and they'll just sink to the bottom of this container and it'll just be collected. They call it a sludge removal tank. It's just basically a big tank filled with mud, that was produced from all this dirty air, being exposed to water. So the thing is, all that sludge would have to be removed. It would probably have to be put into some landfill somewhere. So that's probably a big issue with it. But again, this is a pretty effective way to make cleaner air. Again, dirty air in, cleaner air out. That's the whole point of all of these things. So again, I would choose two of them to really know, like really understand and be able to explain it to somebody else. All right, I want to spend a little bit of time here today talking about something called the Clean Air Act. The Clean Air Act was originally written back, I believe, in the mid 1960s, but It has constantly been altered and amended throughout the years, but the bottom line, the Clean Air Act in our country, in the United States, is what gives the power to the federal government, the EPA, the Environmental Protection Agency, which is a branch of the federal government. It gives our government the power to try and control air pollution. Anything that gets in our air that is harmful to not only human health, but also our welfare. Now, our welfare is like, for example, crops, things that we grow. If our air quality is so bad that it affects our crops and our soil, then that's affecting our welfare. Okay. You know, Animals, ecosystem, anything that can be affected by air quality, even like infrastructure, like buildings, for example, anything that's affected by our air quality, the EPA via the Clean Air Act can investigate it and try to fix the problem. Now, one of the things that has been set up as a response to the Clean Air Act, by the government, is something called the NAAQS, which is also known as the National Ambient Air Quality Standards. This has been set up basically for every single air pollutant, especially the 6 criteria ones that we've mentioned before. And it basically says that, hey, there's only so much of this that we want in our air. Anything that's above that level, we need to investigate it and figure out what's causing it and do something about it. Here's just a good example. Ozone, tropospheric ozone. Ozone is measured in parts per billion. How many parts of ozone are there per part of air, for example? And most of the time it's kind of in a fairly good range, but sometimes it gets into these unhealthy ranges. And the EPA says that, hey, if it gets into these unhealthy regions, let's say, for example, it gets into 200 or 300 parts per billion, then we need to figure out what's going on and we need to control this. At minimum, we need to make sure that people are aware of it. This is why, for example, in Chicago in the summertime, if the ozone level gets too high, you'll hear it all over the news. Hey, it's an ozone action day. You got to make sure you're careful outside. You got to make sure you're not breathing in all this poor air that has all this tropospheric ozone in it. And this is all something that comes from the Clean Air Act. The Clean Air Act says that, hey, we need to make sure that we make people aware of this. And if the ozone continues to stay high, we need to find out what is going on and why why is it that high. This is kind of showing us the pollution trends in the United States. And this only goes back to 1990, but one thing I want you to notice about this is just the way that things are trending. You'll notice, for example, we have all of our criterias here, right? We have our lead, our SO2, ozone, carbon monoxide, NO2, even our particulate matters. These are all on the same chart. And this chart is showing us, it's kind of giving us a reference point. It says here on the left, it says the percentage difference from the air quality standard. So, for example, back in 1990, let's just use SO2 as an example. Back in 1990, in the United States of America, the SO2 levels, the sulfur dioxide levels of our air, were about 75% above what the standard is. So that's not good. Like back in the 1990s, we knew that this was a problem. So what have we done about it? Well, we've implemented SO2 scrubbers in our factories and things like that. And these technologies have really, if you'll notice, it's really helped to lower that. Where today, or more recent times, we're now close to maybe 50 or 60% below the standard. And we still have SO2 in the air, but it's much better now than what it was, let's say, 30 years ago. And we can pretty much say that for just about every single pollutant. The Clean Air Act has done wonders for the air quality in the United States of America. Unfortunately, not every country around the world has a piece of legislation that gives the government the power to help control air pollution measures in their country. There are some countries around the world where this graphic here looks way different, and it's all because the air quality standards are much different in those countries because there aren't any. So that's kind of a big issue. I want to mention a couple more things here. These are called CAFE standards. CAFE standards are basically used in a lot of developed countries. The United States is one of them. But this was another law that was enacted in the 1970s. And again, it gives the government the power to enforce laws that keep car manufacturers responsible for the car emissions that those vehicles produce. We want our vehicles in this country to produce as less or the least amount of pollution as possible. Currently in our country, the standard for, let's say, for example, let's just use Ford, the Ford Motor Company. Ford produces a lot of cars in this country, but right now, the federal government says that all of the cars that Ford manufactures, let's say that Ford makes, I don't know, 15 different types of vehicle. All of those cars, on average, must have a fuel economy of 27.5 miles per gallon or better. If they don't, then they have to stop producing certain types of cars in order to get that level back up. So this really, I mean, if you think about it, these CAFE standards are pretty good. It kind of keeps the automobile industry honest when it comes to their carbon emissions. This was made several years ago. This was from the Obama administration. They came up with their own fuel economy standards about 10, 12 years ago. And the goal, I want to say this was 2010, I believe this was produced. The goal was that by the year 2025, that fleet standard, that 27.5 that we're at today, they want to raise that to 54.5. Now, again, this was just what was proposed. So it basically said to all these car manufacturers, hey, by the year 2025, we want your entire fleet of cars to have fuel economies of 54.5 miles per gallon or better. And the point of that is if that's the case, if that does happen, that will save $1.7 trillion to the consumer because they'll be driving vehicles that get better gas mileage. They'll be saving money at the pump. But also, it helps to eliminate 6 billion tons of carbon emissions, which is a huge deal. So I really look at these CAFE standards as a really good thing. Now, the problem with these is that it is rather political. Usually when there's a change in political regimes, especially in this country, sometimes these standards get rolled back. Sometimes they get pushed back forward again. Sometimes they get rolled back. But I think any CAFE standard is a good standard because, again, it does help to eliminate a lot of pollution, and potentially it could help, again, keep these car manufacturers a little bit more honest. This chart here is kind of showing you kind of where we want to be. Right now, we're kind of hovering around this maybe 20 to 30 range when it comes to our fuel economies, but we want to get up to that 54 and a half, possibly by 2025. Is it realistic? Is it not realistic? At least it's a goal. I look at it that way. It's better than to have this goal than to not have it, and to keep, again, our car manufacturers responsible and keep them continuously looking at this problem of carbon emissions in our country and, again, worldwide. All right, guys, that was a lot today, but thanks for listening, and I will see you soon. Take care.